Your basement isn't cold because it's underground. It's cold because the earth is doing work your HVAC is charging you for. It's 9 o'clock on a Tuesday night in July. You've already eaten dinner, the sun went down an hour ago, and your bedroom still feels like the inside of a bread machine. The thermostat on the wall says 72 degrees. The compressor outside clicked on again 20 minutes ago and hasn't stopped. You check your phone. The Duke Energy app shows your bill is tracking toward $265 this month. You point the fan directly at your face and tell yourself, this is just what summer costs. Meanwhile, 10 feet below where you're standing, your basement is sitting at somewhere around 54 degrees Celsius. It has been doing that all summer. It did it last summer too. It'll do it again next August without you touching a single thing. No compressor, no refrigerant, no monthly subscription to a smart cooling plan. Just mass. Earth, concrete, and stone holding a temperature your AC is struggling to create upstairs, while burning through electricity to do it. Most people don't think of a basement as useful in July. They think of it as the place where the dehumidifier lives, where boxes of Christmas decorations collect a smell somewhere between old carpet and wet cardboard, where the sump pump waits. You open the door, feel the air shift, cooler, heavier, and think creepy, not resource. That's the disconnect this whole video is about. The standard American home is built to be managed by appliances. When it's hot, you run the AC. When it's wet, you run the dehumidifier. When the power goes out, you panic about the backup battery you haven't bought yet. The house is a collection of problems, and the solution to each one is sold separately at Home Depot. But there's an older logic, one that shows up in Amish farmhouses, old root cellars, and a handful of well-built homes from before central HVAC became standard, that treats the house as one connected system. Not a list of machines, but a single organism where cold, air, water, and weight work together without constant intervention. Part of that logic involves something that doesn't make much noise. In some of those old setups, if you stood quietly in the right spot, you'd hear a low sound from somewhere under the floorboards or behind a wall panel. Not a motor, not a fan. A soft, steady purr. The sound of something moving slowly on purpose. That sound is where this story goes. But to understand why it matters, you first have to understand what your basement is actually doing right now, and why you've been ignoring the coldest, most stable part of your house while paying a machine upstairs to build a worse version of the same thing. Here's the thing about that 54-degree basement. It doesn't stay useful on its own. It needs one condition that most American homes quietly violate every single summer. And when that condition breaks down, the same basement that could be your best thermal asset turns into the source of that smell, that dampness, and that dehumidifier that runs 8 hours a day and still can't keep up. The condition is simple. Cold surfaces and warm, humid air cannot meet without producing water. When outdoor air in July sits at 82 degrees Celsius with high humidity and finds its way into your basement through a cracked window you opened to let it breathe, through gaps around pipes, through the dryer vent that isn't quite sealed. It hits your cold concrete walls and cold water pipes and immediately starts releasing moisture. Not because your basement is leaking, not because there's a plumbing problem, because you introduced warm, wet air into a cold space, and basic physics did the rest. That's condensation, and it's happening in millions of American basements every summer while the homeowners blame the foundation. The dehumidifier responds. It pulls gallons of water out of the air over the course of a week. A quality unit like a Frigidaire 50 pint or an HomeLab's 4500 AX FT model can extract several gallons on a bad day. And it does this while drawing 300 to 700 watts continuously. So, you're paying for electricity to remove water that you invited in by opening the wrong vent on the wrong afternoon. The machine isn't broken. The approach is. Old root cellars and Amish-style farm storage spaces handled this differently. Nothing sophisticated, just a set of habits built from watching what stone does in summer. You don't open cellar vents when the outdoor air is warmer and stickier than the air inside. You store things on wooden slats off the floor, never directly on concrete, because the floor surface is coldest and condensation hits it first. You use the natural stack effect, cool air settles, warm air rises, to create slow, passive airflow, rather than forcing it with a box fan that pulls August humidity straight in through the intake. There's also the matter of what's sitting against your foundation walls. Cardboard boxes touching cold concrete become damp from the inside out. The box doesn't feel wet until it does, all at once. Metal lids on canning jars develop a faint rust ring. The wood frame of an old shelf gets soft at the base. These aren't signs of a bad basement. They're signs of surfaces that weren't given any distance from the cold mass. That low purring sound from the old farm setups wasn't decoration or nostalgia. In some configurations, it was a slow belt or a small shaft moving just enough air to prevent the exact stagnation that lets moisture settle and stay. Not a blast. Not a full ventilation system. Just enough movement to keep cold air and warm air from meeting in one dead corner and turning into a problem you have to mop up. Your basement can hold 52 degrees all summer, but whether that makes it a cold battery or a wet sponge depends entirely on how air and moisture move through it. And that part, unlike the temperature itself, doesn't happen automatically. So now you have a basement that holds cold naturally, and a moisture problem that comes from moving the wrong air at the wrong time. The question becomes, how do you keep a slow, stable system actually moving, without plugging in another appliance that hums, trips a breaker, and adds another line to your utility bill? This is where the purring wheel stops being a mystery and starts being an answer. In old Amish farmhouses and pre-electric rural homesteads across the Midwest and Mid-Atlantic, mechanical work didn't start with flipping a switch. It started with whatever was already moving: water from a stream, a weighted pendulum, a hand-cranked flywheel, a belt running off an axle connected to something the farm already needed to spin. The point wasn't to generate massive power. The point was to keep something useful turning at low speed, all the time, without demanding attention. A water wheel on a small farm creek, even a modest one, maybe 4 to 6 feet in diameter, doesn't produce the kind of output you'd need to run a modern home. But it doesn't have to. What it produces is continuous low-effort mechanical rotation. And that rotation, fed through a simple leather belt or wooden shaft into the basement or root cellar, could move a small fan blade, lift water to a gravity-fed tank, or drive a slow paddle that kept air circulating just enough to prevent the dead air pockets where moisture concentrates and mold starts. That's the purr. Not a roar, not a machine trying to dominate the environment. A soft, steady turning that kept the system from going stagnant. Weight-driven mechanisms worked on the same principle. Similar to the movement inside a grandfather clock, a heavy suspended mass, sometimes over 1,000 pounds in larger farm setups, would descend slowly over hours, turning a shaft connected to whatever needed to keep moving. You'd reset it once a day, like winding a clock. In exchange, the system ran quietly and continuously without any fuel, without any electric draw, and without cycling on and off the way a modern appliance does. That cycling is actually a key problem with how modern homes handle basement conditions. A contemporary dehumidifier or basement ventilation fan sits idle, then kicks on hard when conditions already hit a trigger threshold, then shuts off again. The basement swings between neglected and corrected. Old mechanical systems didn't operate on triggers. They operated on maintenance of a slow, steady state. The difference is between a thermostat that reacts and a flywheel that prevents. A company like Bison Pumps or a basic Amatec Rotron blower can move basement air at low wattage today. Some units draw under 15 watts continuously. That's closer to the old logic than a 400-watt dehumidifier running in panic mode. The technology changed. The principle didn't. The purring wheel wasn't magic. It was a machine built around the understanding that a little consistent motion, not a lot of occasional force, is what keeps a stable environment stable. Your basement already holds the temperature. The wheel's job was simply to make sure that temperature stayed useful, instead of turning into a problem the next time someone opened a window on a humid afternoon in August. Once you start seeing the basement as a slow thermal engine rather than a storage dump, something shifts. You stop thinking about it as one room with one problem. You start seeing the whole house as a set of climate zones, and you realize that most American homes are storing the wrong things in the worst possible places. Take the average garage. In Phoenix, Dallas, or Atlanta, a closed garage in July can hit 110 degrees Celsius by early afternoon. The metal door absorbs solar radiation all morning, the concrete floor holds it through the evening, and the insulation is whatever the builder felt like installing in 1987. Yet walk into almost any American home and you'll find the emergency water supply on a garage shelf, canned goods stacked next to the water heater, a chest freezer like a GE 10.6Q, FT, or a Frigidaire 14.4, running in a corner that peaks at 100 degrees Celsius, forcing the compressor to work twice as hard as the manufacturer designed it to. That freezer might cost $40 to $60 a month in electricity just because of where it's sitting. Meanwhile, the basement is 54 degrees Celsius and full of old paint cans and a broken treadmill. Root cellars and Amish-style storage spaces solved this problem before it became a problem. Not by building expensive climate-controlled rooms, but by matching what gets stored to where the house naturally holds the right conditions. Root vegetables, potatoes, carrots, beets, want 32 to 40 degrees and high humidity, so they go in the coldest, dampest corner. Canned goods and preserved foods want 50 to 70 degrees and low humidity, so they go on raised wooden shelves away from the foundation wall. Seed stock, dried herbs, and grain want cool and dry. A different shelf, a different airflow zone. Nothing went into the garage. The garage was for tools and animals, not food. The same logic applies directly to modern emergency preparedness. A gallon of water stored at 100 degrees in a garage degrades its container faster, tastes worse, and puts stress on whatever plastic you're using. That same gallon in a 58 degrees basement stays stable for far longer. Backup batteries, whether a Jackery 1000, an EcoFlow Delta, or a basic AGM battery bank, lose capacity and lifespan when stored in heat. Medications, first aid supplies, spare electronics. All of them have an ideal storage temperature range, and almost none of them benefit from sitting in a garage that turns into a solar oven 6 months a year. The practical move isn't complicated. Raise everything off the concrete floor. Wire shelving units from Husky or Gladiator work fine, so air can pass underneath. Keep bulk food and emergency supplies in the cool, stable zone of the basement, rather than the temperature extreme zones of the garage or kitchen cabinets near the range. Run your chest freezer in the basement instead of the garage if the layout allows it. A freezer in a 58-degree space runs its compressors significantly less than the same unit fighting 95-degree ambient heat. None of this requires a wheel, a flywheel, or any Amish carpentry. It requires looking at the house the way the old farmhouse builders looked at it, as a collection of different thermal environments, each one useful for something specific, all of them already there, already working, just waiting to be used correctly instead of ignored. The Purring Wheel principle scales up exactly this far: slow, consistent, low-effort management of what goes where, so the whole system carries less load. Here's a question worth sitting with. If the logic of using your basement as a thermal buffer, matching storage to climate zones, and keeping air moving slowly is this straightforward, why doesn't anyone explain it when you buy a house? The answer isn't a conspiracy. It's simpler and more mundane than that. There's no product attached to the explanation. Walk into any Home Depot or Lowe's, and the basement aisle tells you exactly what the market thinks your problem is. There's a $279 Frigidaire dehumidifier for the smell, a $49 damp rid hanging moisture absorber for the closet, a $12 can of Rust-Oleum basement floor sealant for the sweating concrete, a $189 Honeywell portable fan for the stagnant air, a $590 Generac battery backup for the outage anxiety. Every product on that shelf is a correct answer to a real symptom. None of them explain what's causing the symptom in the first place. That's not an accident of bad design. It's just how consumer markets work. A symptom has a SKU. A system doesn't. Nobody banned the old approach. Nobody sat in a boardroom and decided that Americans shouldn't understand thermal mass or moisture discipline or the difference between reactive appliances and preventive physics. What happened is quieter than that. As cheap electricity became available, as HVAC systems became standard, as houses started getting built faster and with less attention to passive performance, the knowledge of how a house naturally manages temperature and moisture simply stopped being passed down. It wasn't suppressed, it was replaced by a culture that treats discomfort as a purchasing trigger. The result is a specific kind of expense that's hard to see because it comes in small installments. It's the $260 Duke Energy bill in August. It's the $40 monthly cost of running a chest freezer in a hot garage. It's the $30 in groceries that spoiled because the pantry cabinet sits above the dishwasher and peaks at 85 degrees Celsius after the dinner cycle. It's the $279 dehumidifier that runs daily but never quite fixes the basement because the gutters are still directing water toward the foundation, and the basement window still gets opened on humid afternoons. Each purchase makes sense in isolation. Together, they describe a house that's constantly losing a slow, quiet battle against its own physics, and paying for the privilege every single month. The old farmhouse logic asked a different first question. Not, what machine do I need, but what is the house already doing and how do I work with it? A $15 digital thermometer and humidity meter from Accurite or Govee, placed in the basement, the garage, the pantry, and the upstairs bedroom for 24 hours, will show you more about why your utility bill is high than any smart thermostat ever installed by an HVAC technician. Not because the meter fixes anything, but because it gives you the map before you start buying solutions to problems you haven't accurately located yet. The Purring Wheel wasn't cheap to build. It took time, skill, and maintenance. But the mindset behind it was free. Understand the system first, then decide what needs to move and how much. That sequence, diagnosis before purchase, is what the modern appliance market quietly skips every time it hands you a solution at checkout before you've finished asking the question. So, let's walk back through the same house, but this time with the map. The bedroom upstairs is still hot at 9 o'clock. The AC is still running, but now you know that the heat isn't coming from outside anymore. It's radiating out of the drywall, the ceiling, and the floor that spent 12 hours absorbing it. The machine isn't failing. It's just fighting thermal mass that charged up all day, and it won't win that fight until well past midnight. That's not an AC problem. That's a house behavior you can plan around. The basement door opens the same way it always did. Cool air spills out. But now that number, 54 degrees on a cheap Accurite thermometer stuck to the wall, means something different. It means the earth under your house has been doing continuous free thermal work every single day of the summer. And the only question is whether you've been using it or ignoring it. The dehumidifier in the corner is still there, but you've redirected the downspouts so they carry water 6 feet away from the foundation instead of pooling against it. You stopped opening the basement window on afternoons when the outdoor humidity is above 60%. The canned goods and emergency water moved off the garage shelf and onto a raised wire rack along the north basement wall. The dehumidifier now runs maybe 4 hours a day instead of 8. It didn't get more powerful. The house got less self-defeating. The chest freezer is still running. But it moved from the garage, where it was fighting 95 degrees of ambient heat all summer, down to the basement, where it's sitting in 58 degrees air. The compressor runs noticeably less. The freezer's lifespan just got longer without a single upgrade or repair call. The EcoFlow Delta battery backup, or whatever you've got for outage prep, is no longer stored next to the water heater. It's in the cool zone, charged and stable, not slowly losing capacity to heat it was never designed to sit in. And somewhere, either in the slow rotation of a small basement ventilation fan running at 12 watts, or in a gravity-fed airflow path between a low intake vent and a high exhaust, there's the faint, steady movement of air. Not dramatic, not loud, just enough to keep the cold stable, the moisture from settling, and the system from swinging between neglected and corrected. That's the Purring Wheel, not a relic, not a romanticized Amish mystery. A principle. Small, continuous, correctly directed effort prevents the kind of extremes that make expensive machines necessary. The 56 degree isn't magic. It's stored work. Millions of pounds of earth absorbing seasonal temperature change over months, not hours, turning your basement into the most thermally stable room in the house. Whether that room becomes your cold battery, your food storage, your emergency prep zone, and your natural AC buffer, or stays a dim space full of things you meant to throw away in 2019, is entirely a question of whether you decide to read the house or keep reacting to it. Your home already knows how to stay cool. It's been doing it the whole time, 10 feet below where you stand sweating at the thermostat. The only thing that changed today is that now you can hear it.